Hello everyone, Assalamu alaikum warahmatullahi wabarakatuh. So today I want to explain the topic of adders in digital design. So firstly, I want to explain that what is an adder. An adder is basically what it says. We are adding two separate binary numbers. Okay, so first we're going to begin with adding two bits of numbers. So it's like two separate one bits, right? So I can see an example here. So we're going to see it's basically a half adder, so we call them half adder. So it's like there is x and y, for example, each of them being one bits, right? One of x is one bit, y is one bit. We're adding them both, so we're adding two bits, right? And the output, and we'll get the sum as well of these two numbers being added. So as you can see in this, and then wait, before that I want to say what else we're going to explain. And then after the two bits we're going to explain how we're going to add three separate bits. So we're going to add x, y and z, for example, and each of them being one bits each of them will be one bit, and we'll add three separate bits basically, right? So we'll add them and we'll get an output as well. And then we'll look into how we can add so many different numbers of bigger digits basically. Okay, so let's start with the half adder. So a half adder is basically we add two separate single digit bits, and we call them adding two separate bits, so two bits, right? So addition of two bits, and we can see the output here is 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1. But when you do 1 plus 1 we get 2. The output is 2, and 2 in binary is written as 1 0. So here we are using one single output, which is f is one bit, right? We cannot just put one bit here, we need to put two bits, right? Because the value 2, 1 plus 1 equals 2 needs two bits, right? So we need to have two bits here. And so we change the whole table and we rewrite the table again by in this format. So we have 0 plus 0, the sum is 0 and there is no carry. So what is the carry here? So we change the table into a different format. We have two outputs now, so we have two output variables and two input variables, and the sum here is the value that we get as the output, and C here is the carry. So what is meant by carry? So let's think of an example. If I have 1 plus 1, so I'm adding two numbers, 1 plus 1, right? So I have one in binary, I'm adding in binary. So 1 plus 1, as we saw, the value is 1 0, so the value is 1 0. So we cannot put 1 0 here, we put 0 here, and we carry the 1. So this is the carry basically, right? The carry is this one, and this one we put it directly here. This is not as the carry, this is what we call the carry. So when we add 0 plus 0, we get 0 and no carry. 0 plus 1, we get 1 and no carry. 1 plus 0, we get 1 and no carry. But when we add 1 plus 1, we get 0 and 1 as the carry. This is the basic understanding of what a half adder is. Okay, so this is the half adder. Now using this table, now we've built this table, right? And we can, as we studied before, the min terms and max terms and the k maps and all these methods that we studied, we can use any of those methods, okay, and figure out the formula for each of them individually. So we'll find the formula for this, and then we'll find the formula for this, as you can see here. So using this table, we found the formula for c is xy, the formula for s is x or y basically, okay, or in this format, whichever you prefer, both works. And then using these two formulas, okay, now we can make the schematic for it. Okay, so we have two inputs and we have two outputs, and we make the schematic, and that's how this looks like. So it's very simple here. So c equals xy, x and y, so there is an and in between. So we use the x here, and we take the y from here and we put it here, and we put the and gate here, and we get the c. Similar way we get x here, so we get x from here, and it goes into the XOR, and we take the y, it goes to the XOR. So this is the XOR gate. We get the XOR gate and we get the value s. That's as simple as it gets, right? Okay, so then we can use the exact same thing. I'm not planning to go into Verilog in detail in this video. I'm just going to explain the concepts of understanding how these things work. So if you have any questions, or if you have any doubts, if you want me to explain the Verilog, anything like that, just comment down below and I'll try my best to make new videos or answer them, inshallah. So yeah, this is the simple Verilog. So we have two input variables, we have two output variables, and we add these two. So we have x and y is added to get c. So we have x and y added to get c, x and y added to get c. We are using x and y XOR. We are doing XOR to get s, and that's as simple as it gets. So yeah, now we come to full adder. So a full adder is based. So I hope the x half adder is clear, inshallah. If there is any questions or doubts, as I mentioned, you can put in the comment section, inshallah, down below. Okay, now a full adder is basically we add three separate bits, right? So we can have x, y, and z, but in this case we are using c in. I'll explain in a moment why it's called c in. um, so basically we have three separate input bits. So we have x, y, and c in. We add these three bits and we get an output. Okay, so we'll look at what the output can be. So 0 plus 0 plus 0 we get 0, and 0 plus 0 plus 1 we get 1, and blah 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 blah, we get all these numbers. But in these cases, for example, in this case here, right, and in this case here, and in this case here, and in this case here, in all of these cases, as you can see, we get the values 1 0 1 0 1 0 and 1 1, and these require 2 bits, and we don't need more than 2 bits because the biggest number is 1 plus 1 plus 1. Okay, we cannot have bigger than that because it's 3 bits, and each of them, the maximum number is 1, so it's 1 plus 1 plus 1, and the maximum we can have is 1 1. So it's the 1 1 here, right? It's 1 1 here, and that's the maximum, and therefore the output for 3-bit addition is 2 bits. So the output is 2 bits. So if you have adding 3 bits, the output, the maximum output we need is 2 bits. And so we have the carry out here, and we have the S here. Now the reason why we have carry in is because we don't use full adder by its own, like by itself. We don't use it alone. We always use it together with a half adder. Okay, and we'll come to a bit more details down in the later slides. But the point is that the full adder is not used on its own. The full adder is always used together with the half adder. So we use the half adder first, then we get a carry, and we take that carry into the full adder. Okay, and that's why it's called as a carry in, and it's not called as XYZ. It's called as a carry in because we take this carry from the half adder. Okay, and then after this full adder we get a carry, out here, and this carry out we use it again in another full adder, and this keeps going, and that's why we can chain as many full adders as we can. We keep chaining them, chaining as big as we can, so we can make like additions of huge numbers basically. And now we got these formulas, so it's just simple as it gets. So 0 plus 0 plus 0 we get 0s, the sum is 0, and carry out there's no carry, and the same thing goes on here. For example, we have 0 plus 1 plus 1. Okay, the output is 1 0, so there is 0 in the sum and 1 is the carry. And in this last case there is 1 plus 1 plus 1, we have 1 in the sum and 1 in the carry, and these are the outliers, so I just mentioned them. Now using these outputs, we have the two variables, two output variables, the S output variable and the C out or carry out output variable. We use these two, we find separately the formulas for each of them, or the equations for each of them. We need to make the K-map for the S C out and the K-map for S, each of them separately, and we figure out the formulas. As you can see, she's doing this. I'm not going to detail these things because the K-map is a previous topic. If you want me to explain K-map in a, I think I've made another video of K-maps. I can, yeah, I've made another video of K-maps as well. I can share them in the description as well, inshallah. But basically, the S, we find the S and the C separately. We find the formulas for them, C out and S, and we use those and we draw the schematic for it, and that's the schematic for the full adder. It's a bit long here, but it's not that complicated, I hope. Basically we are using XORs, two XORs here, so X, Y, and Z is put in two XORs. This is basically like, it's like all of them are put into one XOR. Basically here in the diagram it looks like two XORs, but here we do like put into one single XOR. So this way the CX goes here, and the Y goes here, and the C in goes here. We put them all into XOR and we get the S value. Here we have these two are ANDed, these two are ANDed, these two are ANDed, and they are all OR. Like they are all OR with each other, and that's why we have these three ANDs here, 1, 2, 3 ANDs, and one single OR to OR them all. And we get these values as well. And the similar thing, we'll have to do them separately, individually, one by one. We'll have to write Verilog. As I mentioned, I'm not going into details of Verilog in this video, but if you need explanations, please let me know in the comment section, inshallah, and I will try my best to make a video. So this is just a different way of making a full adder, and it's using a half adder to make a full adder, right? That's what it's doing here. As you can see, this part is used as a half adder, and then we make a half adder and we put the half adders there, and then we make the full adder using the half adder. As you can see, this half adder, and then we have the whole thing as a full adder. So we use two half adders to make a full adder. I'm not going into detail of this topic right now, but if you want any topic specifically, I'm gonna make a video if you mention it. And then we have the binary adder. So this is the important topic that I wanted to come to. So basically we have what we're gonna do is we're gonna add n bit numbers. So we'll have huge numbers of n bits. Let's say we have like a 10-bit number or a 4-bit. Let's make it simpler. A 4-bit number, two 4-bit numbers. We take these 4-bit numbers and we're gonna add them. And to add them, we use half adders and full adders. Okay, but as you know, full adders and half adders we only add 1-bit numbers. So a half adder adds two 1-bits, and a full adder adds three 1-bits. Okay, and now we'll see how they actually work. So in this case, let's see, right? We have two 3-bit numbers, right? We have two 3-bit numbers. So the first number is A and the second number is B. So A and B. So each of them is 3 bits each. Each of them are 3 bits. So if you add A0 plus B0, we get A0 plus B0 here. And then we have, let's say this had a carry. If A0 and B0 are both 1, so the values are 1 and 1, right? And if you add 1 plus 1, we get the carry of 1. So the value becomes 0 here, and we get a carry of 1, right? And therefore, what we do, we have to add A1, B1. So we add A1, B1, and we add the carry of A0, B0, right? And that's why we have the three numbers here. And that's how we're going to use the full adder here, right? So we're going to use these two, we're going to use half adder to add these two because we have two digits here. We're going to add two digits or 2 bits basically. And then we have a carry from here that goes into this, right? And this carry makes these two numbers here into three numbers, and that's where we use a full adder. I hope that's making sense. And from here we'll have a carry. That carry will become added here. So these two digits will have a third digit here, and then we'll have a carry from there, and that we'll put it here. Hope that makes sense. And these numbers will be called R0 and R1 and R2 and R3. Hope that makes sense, and I think it's better explained in this diagram here. So we have the A0. So what are A0s and B0s? I hope that is not confusing already. So let's say we have let's say A is, let's say 101. Okay, let's say A is 101, and we have B which is 0, let's say 111. Okay, for example, and then like this. And so we need to add these two numbers, right? So we're going to add these two, we're going to add them, right? So these things, this whole thing is A, this whole thing is B, and this digit we call it A0, this digit we call it B0. This is A1, this is B1, this is A2, this is B2, and that's what's written right here. That's the same thing exactly, right? So what happens with these values is what we were discussing earlier. So basically that's A0. So we add A0 and B0. So we're going to add digit by digit, right? So we look at positions. So we look at the 0th position, we add the 0th position first, and then we add the first position, and then we add the second position, and then we get the full number, right? So we have the A0 is B0. We add it using half adder because there's only 2-digit inputs, and we get the R0, which is the sum from earlier, and we get a carry here. This carry we pass it to the full adder as carry in. Okay, so we added three numbers here. You can see we're adding three separate numbers here. So we add A1, B1, and then we add the carry from the previous addition, right? From the previous position. We add these three numbers, we get an R1, which is the sum of the full adder. We learned a bit earlier, is the sum of the full adder, which is the R1. And we get the carry out. Here there was a carry in, and this one is the carry out. This carry out, we pass it to the next one. Okay, we pass it to the next full adder. So next full adder adds A2 and B2, and we pass the A1, B1's carry as a carry in to the full adder of A2, B2. And then we get the R2, which is the sum of the full adder, and the R3 is the carry of the full adder, and this whole thing, R0, R1, R2, R3, becomes the result of the whole addition, basically, right? So now look at this. This is like a three-bit adder. So we have 3 bits here and the 3 bits here, and we pass these things. This is basically the same thing we just did over here, and we're just wiring it all up, and we make an adder 3-bit. I can explain this in a bit more detail to make it clearer. So we have A0 and B0. So we're passing A0 here into this half adder, and a B0 here to this half adder. We get the result R0, and we directly pass it to the R0 output. Okay, and then we have a carry here, right? We have a carry here. This carry we pass it to another full adder with B1 and A1, and these three numbers are added in a full adder, and we get the result R1. We directly pass it to the outside with the R1 as the result, and we have the carry out. This carry out we pass it to another full adder with B2, right, and A2. So there is A2, B2, and the carry out of A1, B1. We pass them all, we get R2 as one output and the carry out as R3. And these 4 digits gives us the sum of the 3-bit adder, basically. Okay, so we added 3-digit, 3-bit numbers. So 3-bit number is a 3-bit number. We add these two and we get the output as a 4-bit. number. That's basically all there is in this slide. Hope that makes sense. If there is any questions or doubts, please let me know in the comment section, inshallah. I'll try my best to answer them.